Hey everybody! In our previous work, we established some values for our three fundamental trigonometric functions at specific reference angle measures, and just as a reminder, these angles don't need to be in degrees, these can be in radians as well. In fact, we're going to be doing most of our work in radians from this point on, unless it's otherwise specified. So here I'm going to bring up the now familiar graph of sine of theta, which we're going to reconstruct by pulling some of those values off of the table as points on a theta versus y set of axes. Once we had all of those points, again, we have to fill in some additional points now by looking at the reference angles in each quadrant. It becomes rather easy to draw a smooth continuous curve through them. This curve that starts at 0, 0, increases to a maximum of 1 at pi over 2, decreases to a minimum of negative 1 at 3 pi over 2, and then heads back to a value of 0 when theta equals 2 pi, is our basic sine wave. Now you might think that cosine, being the complementary function to sine, should look at least related to the graph of sine, and as we start to move those known points onto our axes, again filling in the values for the reference angles in each quadrant, connecting our points gives us a very satisfying curve here, something that looks very similar to but isn't quite sine of theta. This time though, our curve starts at a value of 1. If you recall, cosine of theta is tracking the x value of a point going around the unit circle, as theta opens up to larger and larger angles. I will link a graph in Desmos for everyone to play with so that you can explore that concept a little bit more deeply if it hasn't quite sunk in yet. Before we move on, however, let's try to visualize how sine of theta and cosine of theta are related here. Can you see what's hidden inside of sine of theta now? How about if we isolate a certain region? As we begin work on transformations of these functions in a later lesson, it'll become a little more obvious what's happening there. As we get into the graph of tangent, just know there is a lot of interesting stuff regarding tangent and where it comes from that's beyond the scope of this video. Grant Sanderson of 3 Blue 1 Brown has been doing some recent live streams on trigonometry, and I'll link to him to let him explain. We'll begin with tangent as we have the other two graphs, plotting known points in quadrant 1 and then extending them through the other quadrants. You might notice, however, the drawing of the function's graph is a little different from the other two. For starters, you'll notice that I started drawing left of the y-axis on this one, beginning with values in quadrant 4. This is because one full tangent wave actually occurs between negative pi over 2 and pi over 2. You'll notice that tangent launches itself into either positive or negative infinity on either side, and we've encountered this behavior before. Here, as theta starts to approach an odd multiple of pi over 2, the output value for tangent of theta becomes infinitely positive, or infinitely negative depending on which side you approach from. This creates some asymptotes in our graph that act as sort of boundary lines, showing the limits of the tangent graph around these x values. We can, as with all of the trigonometric functions, keep continuing around the circle by increasing or decreasing theta, and this will give us a picture of how tangent cycles. Now I know that these weren't exceptionally deep looks at cosine and tangent, but I just wanted to provide you all with an introduction to their general shapes. As we move into transformations, we can define the different features of these graphs and we can begin to explore modeling with waves. As always, feel free to leave me any comments or concerns, and until next time, enjoy!